Okay, here we are on our last section of chapter 6, and we have the Hinge theorem today. But first, let's go back and just review a little bit about what you did last time. And what we want to do is to describe the possible lengths of the third side of a triangle. So if we have a triangle that's 5 inches long and 12 inches long, what is the possible lengths that the third side can be? And there's a range of lengths that they can be. Now, in the lesson video from the other day, went through all of the inequalities and things like that. I'm just going to go through the shortcut, and we want to write this inequality as a compound inequality. A compound inequality means you're going to have the x in the middle, and it's going to basically give you a range of values. Okay, so we're going to have our x in the middle. Okay, when we write a compound inequality, both arrows always point towards a smaller number, so I'm going to have them both point towards the left. And in this instance, the least amount that the side length can be is when you subtract the two values. So 12 minus 5 is 7. And then the most that it can be is if you add the two together, which would be 12 minus 5, or excuse me, 12 plus 5, which is 17. So the shortest that third side could be is 7. The greatest it could be is 17. And notice we do not put the or equal to sign underneath of there, because if it was or equal to, then it would not work. Okay, so now that we know how to basically do it, we're going to have our x here. We're going to point towards the smaller number, subtract 18 minus 12 is 6. And then our largest amount it could be is if we added them, which is 12 plus 18, which is 30. Okay, put our x in the middle, point in the same direction. Smallest it can be is when we subtract, which is 38. Biggest it can be is when we add, which is 42. Okay, smallest it can be is when we subtract, which is 0. Biggest it can be is when we add, which is 50. And notice that I have 0 for a side length. We cannot actually have 0 for a side length, but notice it does not say or equal to here, which is why that's fine, which means it gets all the way close and close and close and close to 0, but is never actually 0, so it can be any decimal, small, tiny little fraction or decimal, almost up to 0. Okay, so the Hinge theorem is a fairly logical theorem, I believe. Okay, and basically what it says, if you have these two triangles over here on the right, okay, and you have, here's a side and here's a side that's the same, here's a side and here's a side that's the same, and then you have the angle that's in between them. Okay, the Hinge theorem says that that whichever angle is bigger, that opposite side is going to be bigger. So if you think about the hinge of a door, okay, the further you open the door, the bigger the angle that it becomes, and the longer that side is. So if you notice, we've got 88 degrees. Okay, across from that we have side XW, and we also have a 35 degrees, and the side across from it is ST. The bigger that angle, the bigger the side, which means that WX is going to be greater than ST, because the angle is greater than the other angle. And then the converse is just the other way around, where if you have two sides, 12 is longer than 9, therefore angle C is greater than angle F. So let's put a couple of these things into practice here. We know it tells us that ST is the same as PR. They are congruent. And we also know that by the reflexive property, that angle there in the middle is the same. We have this side right here, and we're comparing it with this side. Okay, notice that 23 inches is shorter than 24 inches. That's fairly logical, which means that angle in here, let's name these angles here a little bit. We'll call this angle 1, and we'll call this one angle 2. Okay, so if 23 is shorter, that means angle 1 is going to be less than angle 2, or the measure of angle 2. Okay, because this side is longer, or we could also say that angle 2 is greater than angle 1, if we wanted to think about it the other way, because those are both saying the same thing. All right, same idea. We've got a 64-degree angle and a 61-degree angle. We've got our reflexive property here, so we have two sides and then included angle. Okay, the side opposite of 64, 64 is bigger, so the side opposite of 64 is going to be longer than the other side. So if we wanted to compare JK, excuse me, not JK, if we wanted to compare JM and ML, okay, JM is opposite the bigger side, therefore it is going to be greater than, okay. We could also say that ML is less than JM. Either of those would both be correct. Okay, let's see. If PR equals PS, which is marked, and the measure of angle PQR, let's label these. The measure of angle PQR, or excuse me, QPR, we'll call that angle 1. QPR, we'll call that angle 1, is greater than, it says it right there, is greater than QPS, we'll call that angle 2, just for the ease of knowing what's what, okay? And it says that angle 1 is greater than angle 2, which means the side opposite of angle 1 is going to be bigger than the side opposite of angle 2. So which side is longer, SQ or RQ? SQ is going to be longer because it's opposite the larger angle. And then another example here, okay, is they said same thing, PR and PS are equal, which is larger, RPQ, RPQ, so we'll call that angle 1, or SPQ, we'll call that angle 2. Okay, and it says RQ is less than SQ. So RQ is less than, which means it's going to be shorter than SQ. So that means that angle 1 is going to be less than angle 2 because the side opposite of it is less than the side opposite of angle 2. We could also say that angle 2 is greater than angle 1. Okay, so now let's think a little bit here. We have a situation where Joe leaves home and drives 100 miles due west, then turns 20 degrees towards the north and drives another 50 miles. So they want us to sketch a picture of what this actually looks like. Okay, so let's put up top up here a compass, or I'll put one over here. Okay, so remember, we have our compass, never eat soggy waffles, okay? So we have Joe, and he leaves home and he's driving west. Okay, so let's put here his home, and he drives 100 miles west, and stops. Okay, so here is 100 miles, then turns 20 degrees due north. So from here, this is where it gets a little bit confusing. Maybe you have to read it very carefully. He's turning 20 degrees due north, which means this angle here is 20 degrees, and he travels another 50 miles. Okay, which means if this red angle here is 20 degrees, that means that inside angle, where we're actually going to use to compare how far away he is from home, is going to be 160 degrees. And this distance right here is how far he actually is from home. Okay, we don't know that exact number. We're just going to compare to how far Jenny is from home. Okay, so Jenny leaves home and drives 100 miles north. So here's home. I drive 100 miles north because I went straight north, 100 miles, then turns 30 degrees towards the east, okay, which means 30 degrees towards the east would be me turning about like that, which is 30 degrees. And then I drive another 50 miles. Drive another 50 miles. Sorry if there's a little glitch there. And so then after I travel this far, the question is that I'm going to compare is who is further from home, Jenny or Joe? Okay, well, if this angle here is 50 degrees, or excuse me, not 50 degrees, is 30 degrees, that means that angle on the inside that I'm using to compare is 150 degrees, because remember these are straight linear lines right here. It's a linear pair, so they have to add up to 180 degrees. And if I have 150 degrees that I'm comparing here, I have 160 degrees that I'm comparing here. 150 degrees is less than 160, so that means that Jenny, this distance is going to be closer because the angle is smaller. This one is going to be further because the angle is larger. So who is further from home? It'd be Joe is further from home because his angle that he was traveling at away from home was a larger angle. So you can go ahead and, oh, I think, is there one more? Oh, nope, we don't need to do this homework. There is a class kick that has questions like this that you can complete, please, and let us know if you have any questions whatsoever.